Tonight's kit build is assisted by Night Train Vanilla Porter from Barnhammer Brewing in Winnipeg. Not much in the way of tasting notes in the can, they just describe it as smooth, dark fruit, and vanilla flavors. Well, that's quite nice. So tonight, I'm doing another kit build. Here is the Universal Solder big box of kits that they sent me. All kinds of stuff in here. Let's just, what is this one? Number 26852. Let's do that one. Not even going to bother looking it up. You can if you want to, but we'll find out soon enough what this is. We'll look at the circuit board in a minute. We'll see if we can figure it out from what we got in the kit. We have a potentiometer, we have terminal block, IC socket, switch, barrel connector, and the meeting female side, capacitor, 100 microfarads, a couple of resistors, little ceramic capacitor, one transistor, an S9013, which if I recall correctly is just a basic little NPN. We have a relay. So we're switching stuff on and off. We have an LED, which presumably goes with the relay to indicate that it has happened. We have two little diodes here, a couple of resistors, and a chip, which is a CD4069. I believe that's a relatively standard CMOS logic chip. But let's go and take a quick peek. 4069 is a CMOS hex inverter. Okay, that's in the ballpark of what I thought it would be. And there's all that's inside it. We have 6 just basic inverters. You give it a binary 1 or a high on the input, and it gives you a low on the output. You give it a low on the input, it gives you a high on the output. Fairly wide supply voltage, up to 20 volts. That's kind of nice. That's also fairly typical of a lot of the CMOS chips. The other interesting thing about it is it has a very high input resistance, such that the input signal current is incredibly low, way down in the microamps range. So did you guess from just the components? This is a touch light switch with an off delay timer between 0 and 60 seconds. So what I believe that means is you touch it, it triggers and goes on, and then it just, times out to go out. So presumably that capacitor and one or more of the resistors is going to be making up that time delay. But we'll find out in short order. Here is the schematic from the website. So we have power coming in, 5 volts. I was wrong about that capacitor. That is just a smoothing capacitor to stabilize the incoming power supply. Okay, so we have the touchpad here, which is just 2 contacts. So it's not a capacitive touch. This looks like it uses the resistance of your finger across those 2 contacts as the touch. So this first section of the hex inverter is held high with a really high resistance resistor, 10 meg. And if you touch here, then the resistance of your finger, which will be lower, presumably, unless your skin is incredibly dry, will cause this thing to go low and flip its output. That flipped output, because of the inverter, will be high, because that's been low. Goes through a diode just for steering. There we have the timing capacitor, 100 microfarad. And the timing resistor, the potentiometer. Okay, so when you pull this high, that immediately discharges the capacitor. Both sides will be high voltage, 5 volts essentially. Then when this goes to 0, the diode will block any voltage going back there, so this will discharge. I guess it will charge actually through this potentiometer, whatever it's set to. Meanwhile, this signal here, whether it's high or low or somewhere in between, goes through a couple more stages of inverters, just basically to act like a threshold detection. So that will, if that's high there, that will invert to low and invert it back to high again. Through a base resistor, just to current limit the base current on the transistor. And a high there will turn that on, which brings this to ground, which turns the relay on and turns the LED on. Then when that turns off, the collapsing magnetic field in the relay is shunted back through the diode here. And then your load over here can be whatever you want it to be, up to the rating of the relay. As usual, I'm going to use this circuit board holder. It's just the most convenient, the one that I've got in the bunch of circuit holders that I've got. So where to start? Typically, I like to start with the physically smallest, lowest profile components that are least likely to be damaged by subsequent abuse in soldering and heat and whatnot, which are almost always resistors and ceramic capacitors. And here we have 2 or 3 resistors and 1 ceramic capacitor. I'll probably follow that up with the diodes, the LED likely, relay chip socket, and then potentiometer on the ceramic capacitors over there. Maybe I'll leave that till later just because it kind of gets in the way with the way the board's being held. Anyway, and then the connectors and stuff last, just because they're biggest and will be in the way. So since the board just has component designations on it, I can't go completely wild. I have to refer back to the schematic on the website to see what the components are. So I'll quickly measure them because, you know, colorblind things. That one is a 1K resistor, which according to the schematic is R3, the base resistor for the transistor. And R3 lives down there. For this project, I'm going to use a tool that I'm not all that comfortable using. I'm not all that accustomed to using. This is the lead bender former thing that Universal Solder also sent me. No, I'm not shilling for him. Yeah, I kind of am. He's not paying me. He just gave me this stuff. And I like to support a Canadian company when I can. So, what spacing do I need here? No, I guess I have to use that spacing there. Just bend that guy down. And it should just drop right in with no drama. Just like that. Right. What are these other 2 resistors? That one is the 10 meg, so that is the pull-up resistor. This one over here, which is R1. R1 is up here. It's even laid out kind of like the schematic is. There's the diode there. Theoretically, this last one should be the 220 ohm, which is, yep, the current limiting resistor for the LED, which goes right up here. I can't see, the camera's in my way. For tonight's solder, I'm going to keep this Canadian. I'm going to use this ancient spool of Radio Shack solder that I've had for 20 plus years. Made in Canada for Radio Shack division of Tandy Electronics, Barrie, Ontario. Let's see if it still works. Of course it does. It is a little bit thick. It's actually bigger than my solder tip, but that's fine. I have done so much soldering over years and years with this stuff ever since I was a kid. Not this particular spool, of course. This is, you know, I've gone through several of these. And when Radio Shack was going out of business in Canada, I stocked up. I think I've still got another one of these out in the garage somewhere. Okay, I think I am going to reorient this in the holder a little bit so that I can put that ceramic capacitor on. It is a 104, which is, well, I mean, you could change that out if you want to change the timing constant of the circuit to create a longer or shorter delay. What else should I put the hard way? That just leaves me with a forest of component leads in the way. I can't get at what I'm doing, so because this is a fairly low component count kit anyway, I'm going to do just a couple of components at a time. That's way too much solder because, of course, this stuff is stupidly thick, but I made it work. All right, what's not going to get in my way next? I think the 2 diodes, and they are just the same diodes. They're just basic little diodes. In the habit of bending stuff by hand. I've done it for years. I've got to get used to using a new tool. That's 1 diode, and again, like I said, they're both the same, so it doesn't matter which one goes where. Just got to make sure you pay attention to which direction the band goes. Would I recommend using massively oversized solder like that? No, but it works. What's next? Maybe this capacitor, it's not in the way of anything else. That goes there. The positive is marked on the right-hand side there. The negative is marked on the left-hand side here. Just making sure. And since that goes directly across the power lines, if I did have it in backwards, it would be spectacular and somewhat smoky and probably a little bit noisy for a very short period of time. Okay, what else? I guess I can put the socket in now because there's nothing else going to be in the way of it. The notch indicating pin 1, that dot indicating pin 1 is right there on the socket. That notch indicating pin 1 is over here. I've already straightened all the pins out on that thing. Sometimes they get pretty badly abused in shipping. Now, normally to hold the component in when I'm flipping the board over, I'll use a bit of blue tack. But I'm going to try something that I saw somebody else doing on a different channel, and that's using a bit of Kapton tape to hold it in place. Kapton tape is, of course, very heat resistant. It's electrically insulating too, but that's not important for this application. It appears that I've used a bit too much, but once I've soldered down the first couple of pads on diagonally opposite corners just to hold it in place, then I can peel the tape out of the way and get to all the pads. Plenty of flux. That's one good thing about this huge solder. It does give you lots of flux to play with, but I'm going to have to clean that off afterwards. Not a huge hardship though. Right, what else are we going to put in? Is the LED? Sure. And just a reminder on LEDs, the long lead is positive, the short lead is negative. And on the edge of the case, there is a little flat spot marking the negative as well, just so you've got a couple of different indicators. And to go along with that, on the board, on the silk screen, there is a flat spot on there indicating the negative. So you just match those guys up and you should be good to go. Let's get one lead tagged down here. What's going on? Oh, that's the negative side. Okay. Now that that's in place, I will just reflow that with my finger on the top just to make it nice and flat. And then I'll get the second one in here. What's next in bigness? I want to leave that transistor to the last if possible because it's the most likely thing to be damaged from soldering, even though, you know, it's a fairly rugged old school NPN transistor, but still good practice when you remember to do it. Let's put the relay on. The relay claims to be able to do 3 amps at 125 volts AC on the load side, and of course the control side, the coil is 5 volts. Not sure if you can see the tracks on the board. Those are heavier than the rest of the tracks, and they are relatively short. Could you do 3 amps on there? Maybe. The spacing's not too bad. I don't know. Govern yourselves accordingly. I'm probably only ever going to use this for low voltage, low current applications, but it's still fun to play with. Pins are a little bit bent on the relay. Let's drop him in there. There we go. I'll just solder one pin. One of the ones is not being used. Then I'll give it a reach around, push, and resolder that. There. Now it's solidly on there. Diagonally opposite, and push. I felt a little bit of movement there. And now we're good. Connectors next, I think. There is our output connector. For that one, I think I will use a blob of blue tack just to hold it in place. And while we're in the neighborhood, let's put on the 5-volt input barrel jack here. And we'll solder those guys on too. These larger pins are more appropriate for this oversized solder. You can get a lot of material in there in a short period of time. Plus, it's just not splashing against the neighboring pads. Next, let's put this switch in. There's no place for this switch to go. Oh, okay. Free extra component. Thank you, sir. It does say on the listings on the web page for several of these universal solder kits is that occasionally they'll throw in some extra components so you got spares so you can just add to your collection. And in this case, I've randomly got an extra push button. So that leaves the only component remaining to solder in, the transistor. And once again, the silkscreen shows us what direction the transistor goes in there. You could also trace it from the tracks on the back using the schematic, but on a well-designed kit like these universal solder kits, the silkscreen layout is completely adequate for telling you what you're doing in most cases. I think this is the last 3 solder connections that we have to make. I think. Unless I'm not paying attention here. There. And I don't think I even shorted anything. No, that looks good. I'm going to give the board a quick once over just to make sure that my oversized solder hasn't bridged anything. I don't think it has, but it's always good to check. I'll clean up that flux later. That's not all that important to what's going on here. The last thing to do is just to insert the chip. First, making sure that the pins are all straight and fairly aligned. If you need to squeeze them in a bit, you could just flatten them against there. But I happen to have this little tool here that Larry sent me a long time ago. Handmade little wooden tool. So I'm just going to use that to straighten the pins out. And we should be good to go. Remembering, of course, that the notch on the chip matches the notch on the circuit board and the notch on the socket. That just sets in there. Verify that all the pins went in straight, none of them are canted over, and make sure it's solidly in there. And we're done. Although we do have the touch pads there, which are just a set of pads, you could run wires out to anything. I think I am going to add just a couple of little 90-degree header pins on there, just so that I can get my fingers onto it more easily. You could do anything you want, and of course those header pins could feed off to some wires that go somewhere else. But for the demonstration here, I will just literally touch them with my finger. Right, now we're done for real. All we have to do is get power onto it. One moment, please. Alright, I've got it hooked up here. I've got power coming from my power supply, 5 volts. I've got it set to current limit, but whatever. I've got a meter connected to the outputs here. Power on. The meter is showing continuity. Looks like it's timed out and no continuity. And the current draw is almost nothing. So when I touch these pins, there we go. And I guess if we crank the potentiometer, which direction? Let's go that way. We should have either a longer or a shorter. We got a longer timer. Okay. Quite a bit longer. Cool. I'm assuming if we turn the other direction, it should be almost instantaneously off. Let's give that a try. 10-turn pot. I think I've got it all the way down there now. It won't even go. Okay. So that drags it right down. Yeah, I guess that makes sense. If that potentiometer is set all the way down, then basically that just shorts that right to ground and nothing happens. Okay, so you do have to have the potentiometer set a little bit higher than nothing, which I guess makes sense too. There's a couple of turns, and that's enough. That's just a really short delay. Cool. Well, that's a neat little circuit and a good demonstration of an RC time constant, a good demonstration of using hex inverters for a couple of different things, and also, I guess, a good demonstration of that voltage divider using skin resistance, which is, oh, what is skin resistance anyways? I'm assuming it's less than 10 meg anyways. Put those both in the same hand. They're not touching. They're about a centimeter apart. We got between 4 and 5 meg, depending on how tight I hold it. Oh, what if I go this way? 7.5, so theoretically 8. Again, if I squeeze harder, it makes better contact. If I dampen my fingers, it'll probably make better contact as well. Oh yeah, much better. So yeah, that is the principle of operation. That's a good demonstration of a few different very basic principles, all in one handy dandy little circuit. That was fun to build. I hope you found it interesting, entertaining, maybe even educational. If you want to pick up one of these kits for yourself, I'll put a link to Universal Solder's website down in the description. This kit's only $7 Canadian. Neat little circuit, and as I said, a good education on a few basic principles of electronics that are just handy to have in your memory. Anyway, thanks for watching. I appreciate it as always. Questions and comments down below. I'll talk to you later.